Hi guys, welcome back to my channel. Myself Bharatji. Today I am here with a small topic, Introduction to Klein 4 Groups. Let us move into the video. The Klein 4 Groups is a fundamental algebraic structure in mathematics. It is the fundamental algebraic structure used in the mathematics. It is a special type of group that has unique set of properties and applications. These four Klein 4 groups have a name unique properties and applications in various fields from groups related to the physics and mathematics. For the beginning, definition of the Klein 4 group. The Klein 4 group denoted as V4 or K4. These four groups can be denoted as V4 or K4. It is a group of four elements which specifies the set of operations. This group contains four elements which specifies a set of operations. It is an algebraic group, meaning that order of operations does not affect the result. The group has four distinct elements and satisfies the group axioms. These four groups satisfies the group axioms. Properties of Klein 4 groups. Commutativity, isomorphism, self-inversive elements. These are the three main properties of these four groups. Commutativity, the group operations are commutative, meaning that the order of the element does not affect the result. The meaning of isomorphism, this is the second property of the Klein group. The Klein 4 group is an isomorphic the direct product of two cyclic groups of order 2. This style, these self-inversive elements. Each element in the group is its own inverse, meaning when an element is combined with itself, the result is the identity element. When the elements are combined with the same elements itself, the result obtained from those elements is identical. Examples of Klein 4 groups: symmetries of square, voltage groups in electric circuits, subgroups of large groups. These are the three main examples of these four groups. First one, symmetries of square. The Klein 4 group can be represented by the symmetries of a square. The symmetries of a square is used to represent the four groups of this Klein, including rotations and the reflections. This voltage groups in electrical circuits. In electrical engineering, the Klein 4 groups can be used to model the voltage relationships in certain circuits. These voltage circuits are used to monitor the voltage relationships in certain circuits. Subgroups of large groups. The Klein 4 groups often appears as a subgroup within a large group. The file for group always appears as in a subgroup within the large group structure such as the dihedral groups of order 8. The geometric representation of Kyle for group. Cubic representation and graphic representation. Cubic representation and graphic representation are the two forms of representation which are used to represent these four groups. The four groups can be visualized as the symmetries of a cube. The cube when we represent these four groups, it can be assumed as in a cube where the four elements are corresponding to the various rotations and reflections. The elements the four groups contains the four elements are represented the various rotations and reflections. Graphic representation. The Kyle 4 group can also be represented as a green where the four elements are the vertices and the edges represent the group operations. This graphic representation and other form of representation represent the four groups. The file core group is represented as a graph where the four elements are the vertices and the three edges represent the group operations. Let's move to next topic. Applications of this four group: physics, cartography, group theory. These are the three main applications of this four groups. The Klein 4 group has applications in the quantum mechanics and the study of particle physics. Quantum mechanics and particle physics uses this Klein 4 groups particularly for their explanation and the problem solving, particularly in the analysis of symmetries and conversion laws. This particular physics symmetries is used to analyze and convert the laws. Choreophotography. The properties of the Klein 4 groups are used in the design of a certain cryptography algorithms and protocols, providing a secure and an efficient way to encode and decode information. Theory. As a fundamental group structure, the Kyle-4 group is an important topic in abstract algebra and a group theory with numerous theoretical and particular applications. Relationship to the other group structures, subgroups, direct product, quotient groups. These are the three main relationship subgroups. The four groups can be found as in a subgroups with a large group structure. The large group contains the subgroups such as the dihedral group of an asymmetric group. Direct product. The Kyle 4 group is an isomorphic to the direct product to two cycle groups of an order 2. Quatic groups. The Kyle 4 group can also be obtained as a quatic group of other structures such as dihedral group of order 8. This dihedral group of order 8 is used to represent the quotient groups of the four groups. Next, at the end, conclusion. Fundamental group structure, widespread applications, connections to other groups. The four groups is a fundamental algebraic structure with a unique set of properties and applications. These four groups have a unique set of properties and applications. Widespread applications, the five core groups are an important point of applications in various fields such as including physics, cartography and other group theories. Connection to other groups, the Kyle 4 group is closely related to and to be found within other group structures such as the dihedral group of a symmetric groups. At the end, thank you for watching my video. Please like, share and subscribe.